Hello everyone, course BSc, subject Physics, paper Quantum Mechanics, Astrophysics and Nuclear Physics. Subtopic Nuclear Physics. So here Rutherford's experiment of alpha particle scattering presented by Bommalingaya B, Assistant Professor, Department of Physics, Srimati Sri YER, Government First Aid College, Pavagada. So in our earlier lessons, we have studied about different properties of matter like mechanical, thermal, electrical and magnetic properties. In order to study the micro level details of such properties of the matter, it becomes imperative to know the inner structure of the atom, which is primarily responsible for such properties and other effects. So, first of all, we have to know the structure of the nucleus. An atom is electrically neutral under normal conditions, but some atoms are radioactive, which emit negatively or positively charged particles, beta rays and gamma rays. Hence, it was assumed that the atoms are made up of equal number of positive charges and negative charges. In the year, Sir J.J. Thomson discovered the existence of a very small particle which carried a negative charge. This particle was called the electron, and later on it was found that the charge of the electron E is equal to 1.602 into 10 power minus 19 coulomb and mass of the electron equals 9.1 into 10 power minus 31 kg. So, first of all, we have to know the atomic model, how it was developed, and development of atomic theory by J.J. Thomson's model. So this indicates the structure of the atoms, and here the arrangement of electrons also shown here. So here at the center there is a nucleus, and surrounding the nucleus there are number of electrons. Here positively charged particles are there. There are 7 positively charged particles and surrounded by 6 negatively charged particles. So therefore the atom consists of equal number of electrons and equal number of protons or positively charged particles. So how it was developed? Let us see. So experiment by J.J. Thomson showed the existence of electrons. Radioactivity proved the facts that atom consists of positively and negatively charged particles. As the atom is electrically neutral, the positive charge must be equal to the negative charge. So therefore, the question arose as to how the electrons are arranged in the atom. Thomson suggested that the atom was spherical in shape. This is a spherical in shape. The whole mass of the atom was evenly distributed and the positive charge was distributed all over the mass. The electrons with negative charge were embedded within the atom as shown in the figure. The whole positive charge of the atom was equal to the total charge of the electrons. The atom was like a plum pudding. The electrons oscillate or vibrate about their mean position. The Thomson model could be successfully applied in simple gas laws and simple physical and chemical problems. The characteristics of Thomson's model. So it explained the emission of electrons by eating as thermions and in photoelectric effect. So it proved a mechanism for the emission of electromagnetic waves, which is supposed to be emitted by the oscillating bound electrons in the atom. It provided an elastic ORD model required for the kinetic theory of gases. The dimensions of the atom were assumed as given by the mean free path and van der Waals considerations. It explained the existence of positively charged and negatively charged ions. A gain in electron by the neutral atom produces a negative ion, and the loss of the electron by the neutral atom produces. So therefore, failure of Thomson's model. The scattering of alpha particles by the heavy atoms studied by Rutherford led him to the idea that the positive charge could not be distributed evenly in the whole mass of the atom. Rutherford atomic model, the plum pudding model, is given by J.J. Thomson, failed to explain certain experimental results associated with the atomic structure of the elements. Ernest Rutherford, a British scientist, conducted an experiment, and based on the observations of this experiment, he proposed the atomic structure of elements and gave Rutherford atomic model. Rutherford's alpha scattering experiment. Rutherford conducted an experiment by bombarding a thin sheet of gold with alpha particles and then studied the trajectory of these particles after their interaction with the gold foil. Rutherford, in his experiment, directed high energy streams of alpha particles from a radioactive source at a thin sheet 100 nanometer thickness of gold in order to study the deflection caused to the alpha particles. He placed a fluorescent zinc sulfide screen around the thin gold foil. Rutherford made certain observations that contradicted Thomson's atomic model. So here is the lead box. Here is the lead box that is called an oven, and a radioactive substance is kept here. Therefore, so it emits alpha rays and gamma rays continuously. So these rays are passing towards the gold foil. So here in between there is a slits. The sharp after passing through the slit, a sharp beam is obtained. So here gold foil is kept. So here there are number of atoms are there, gold atoms. So through which the alpha rays are scattered. Here the deflection of deflection screen. Here there is a deflection screen. So at some distance there is a kept camera or resolution camera is there. So on that camera or by the camera, the alpha particles are captured, or deflection of the alpha particles are captured in different angles. We can see further diagram. In another diagram is also, so this is the vacuum. The whole apparatus is kept in vacuum. Here the alpha particles are entering into the gold foil, and at the gold foil there are number of atoms are there. So collision between the alpha particles and the atoms, the particles are scattered like this. There are different directions. So, and some alpha particles will be scattered back. So therefore these are the undeflected alpha particles also there, because after passing through the center, some particles will be deflected or some particles will be undeflected. Scattering of alpha particles can be seen in the diagram. So this is the fluorescent screen is kept for number of scintillations counting. Rutherford scattering experiment. This is the atomic model. Electron shell is the red dots shows that there is a nucleus and reflected beam. Some beams will be reflected back by making the same angle, and some angles are reflected in above 90 degree, or some rays are reflected 90 degree and more than 90 degree also. Rutherford scattering experiments. So these are the electrons. These are the electrons surrounded by nucleus. So expected results. So this must be happen. This must be happen in the theory, but it is contradicted to this, because here actual results. This is the expected results and this is the actual results after experimenting the theory. After experiment, so we will see like this. Diffuse positive charges are diffused here, electrons scattered throughout like this, and here also diffusion of electrons like this, and there is a nucleus at the center. So due to the nucleus, some rays, some alpha rays will be deflected like this. Some alpha rays will be deflected like this. Some alpha rays will be passing like this. So these two diagrams shows that expected results and actual results. Rutherford scattering experiments. This also indicates the scattering of alpha particles, and some rays will be reflected back and some rays will be directed, or some rays will be deflected above 90 degree and below 90 degree some rays. Observations of Rutherford's alpha scattering experiment. The observations made by Rutherford led him to conclude that a major fraction of the alpha particles bombarded towards the gold sheet passed through it without any deflection, and hence most of the space in atom is empty. Some of the alpha particles were deflected by the gold sheet by very small angles, and hence the positive charge in an atom is not uniformly distributed. The positive charge in an atom is concentrated in a very small volume. Very few of the alpha particles were deflected back. That is, only a few alpha particles had nearly 180 degree angle of deflection. So the volume occupied by the positively charged particles in an atom is very small as compared to the total volume of the atom. Rutherford's model of an atom. So this is the Rutherford's model of an atom. Here there is the path of the electrons, so in which the electrons must be revolved. So here the electrons are surrounded by nucleus. So at the center there is a nucleus. Alpha particles are highly energetic, positively charged particles emitted during the radioactive decay of certain heavy elements like uranium, radium, polonium, etc. Alpha particles have 2 units of positive charge and about 8,000 times heavier than electrons. Rutherford hoped to investigate force experienced by them during their passage the atoms of the metals. Some of the alpha particles were deflected through more than 90 degree on their passage through a thin gold foil. Alpha particles are highly energetic, positively charged particles emitted during radioactive decay of certain heavy elements like uranium, radium, etc. Alpha particles have 2 units of positive charge and about 8,000 times heavier than electrons. Rutherford hoped to investigate force experienced by them during their passage the atoms of the metals. Some of the alpha particles were deflected through more than 90 degree on their passage through a thin gold foil. A large angle scattering of alpha particles can be due to the attraction by the negatively charged electrons or repulsion by the positive charge in the new atom. Rutherford interpreted that presence of very small entity in a strong positive charge which causes a strong force of repulsion on the alpha particle. So this small entity carrying a positive charge called nucleus. Rutherford found that majority of the alpha particles were scattered through small angles, but some alpha particles scattered through large angles, that is anomalous scattering. So here are the references. There are some books through which you can study for getting more information.